Okay, we will continue problems using generating function. So before giving the question, let me explain something. That is, we know generating function g of x is given by this, right? G of x is summation n is 0 to infinity a n x raised to n. So when you expand, we get a0 x power 0 plus a1 x plus a2 x square plus etc. So this is actual generating function. In some problems, you may come across equation that is summation n is 1 to infinity a n x raised to n. So instead of 0 to infinity, you may come across. So now we'll continue with problems using generating function, that is solving recurrence relation using generating function. Before going to the question, let me explain something. That is, we know that g of x, what is g of x? G of x is generating function and it is given by summation n is 0 to infinity a n x raised to n. And when you expand, you get a0 plus a1x plus a2x square plus etc. Right? When n varies, x power 0 is 1, so you get a0, then you get a1x power 1, that is a1x1 plus etc. Now when you come to summation n is 1 to infinity a n x power n. So instead of this 0 to infinity, in some questions or in some problems you may come across a summation like this, that is 1 to infinity. So what is the expansion? When n is 1, a1x. When n is 2, a2x square plus etc. a3x cube. It goes on like this. Now this is equal to a1x plus a2x means, you see in g of x, a1x plus a2x square plus etc. So you have a1x plus a2x square plus etc. So what is missing here is a0 is missing. So what is a1x plus a2x square etc. You can take this a0 to the other side. That is g of x minus a0 is value of this summation. Okay. That is a1x plus a2x square etc. is g of x minus a0. That's what you get, g of x minus a0 here. You can substitute directly when you come into a problem. When you come across an equation like this, you can substitute directly g of x minus a0. Okay. So now let us next equation. Let us look into the next equation. Here the next equation is summation n is 2 to infinity a n x power n. So expanding a2 x square. When n is 2, we start with 2. Then a3 x cube plus etc. So here you see a2 x square means it will be from this a2 x square plus a3 x cube plus etc. So what are the terms missing? a0 and a1x. So when you take a2 x square, that is this much, a2 x square plus a3 x cube etc. You can take these two terms to the other side. So g of x minus a0 minus a10 is value of this. Okay. So value of this is g of x minus a0 minus a1x. So when you come across some equation like this, if it starts with 2, you have to subtract two terms of the generating function, minus a0 minus a1x. Okay. So if it starts with 3, you have to subtract one more term, minus a2x square. Likewise, you have to remember how to apply this concept, that is generating function here. So now let us go to the next summation. Next summation is n is 1 to infinity, but here a n minus 1 x power n minus 1. Come on, expand it. In this summation, when n is 1, 1 minus 1, 0, a0. When n is 1, x power 1 minus 1, x power 0 is 1. So we get a0 only. When n is 2, 2 minus 1, a1. When n is 2, x power 2 minus 1, x. You get this. When n is 3, a3 minus 1, 2. 3 minus 1, 2. So a2 x square, it goes on like this. So you see a0, a1x. Here also we have a0, a1x plus a2. Same. Values are same. So you can substitute g of x instead of that. Okay. Then when you come to the next summation n is from 2 to infinity. So when it is 2 to infinity, how it will be? Expand it. When n is 2, you get a0. When n is 3, you get a1x1, x power 1. When n is 3, a2 x square. So here also you get the same value of g of x. So this is also equal to g of x. So when you come across summations of this form, it is enough you directly substitute. Okay, you can directly substitute these values. So you can learn these values so that you can substitute it in the problem. Okay, so here is a recurrence relation. We are going to solve using generating function. Solution, you take down the recurrence relation. First step. Second step, we have to take summation and multiply by x raised to n. That's what we learned, right? So multiplying each term by, you see, x power n, second term by x power n, third term by x power n, and you take summation for each term. But n is from 2 to infinity. So you have to look into the question and you have to take the summation. N is from 2 to infinity. N is from 2 to infinity. For each and every term you have to take that. Now next step, we are going to make some alternative arrangement so that you can substitute g of x here. First term, there is no change. Second term, you see, you can split this, x into x power n minus 1. So you see, x power n, you can write it in terms of x power n minus 1. So what you have to do? Adding and subtracting 1. Now combining the terms, x power n minus 1 into x power 1. So you get this. That is x into x raised to n minus 1. Similarly, when you have to make this in x power n minus 2 form, you add and subtract 2. Subtracting 2, adding 2. Then you combine x power n minus 2 into x power 2. Okay, x power n minus 2 into x power 2. Now this is x square into x power n minus 2. So this is in terms of x power n. The same formula. Okay, same variable. X power n, when it is in terms of x power n minus 1, you multiply by x. When it is in terms of x power n minus 2, you multiply by x square. So it is enough you learn this directly. This is the steps. These are the steps how you got the final step. So now, so here instead of this x power n, we write x into x raised to n minus 1. X is taken outside, okay. This 7 and x is taken outside. So x into x raised to n minus 1. In the next term, since you have a n minus 2, x power n can be written as x square into x power n minus 2. So that x square is taken outside. X square into x power n minus 2. That's what we have applied this to equation there. Okay, instead of x power n. So after this, what we are going to do is, let us substitute the value of this one, this, you see, this one and this value. So you know, this value is g of x. Just now we derived, right? You see this first value, n takes value from 2. So you have to a2 x2. You have to subtract 2 terms. That is, n takes value from, this means you have to subtract, this is the value here. Okay, n is 2 to infinity. An x power n is nothing but g of x. If it is 2, you subtract the first 2 terms, these 2 terms, minus a0 minus a1x. That is the first term. Okay, then second term, summation n is 2. When you take 2, you substitute it here. 2 minus 1, 1, a1 x1, a1. So this starts from a1 x1. So g of x minus a0 you should take. It starts from, you see, a1 x1. It starts from a1 x1. So you have to subtract g of x minus a0. So that is the second term. Okay. Then third term, n is 2 to infinity, n minus 2 x n minus 2. So you have that. You see this one. When n is 2 to infinity, a n minus 2 x n minus 2 is nothing but g of x. So you can substitute g of x here. So after substituting, just expand it. Okay, we expand it. Take the 7x inside. So you get this. Then you take 10x square. Okay, 10x square g of x. Now it is given in the question a0 is 10 and a1 is 41. So instead of a0 you substitute 10, and instead of a1, is there a1? Yes, a1 is 41. You substitute it because it is given in the question. a0 is 10 and a1 is 41. So after substituting, we have to combine all the g of x term. Combine g of x term, that is the first term coefficient is 1. Here minus 7x, here 10x square. So you get like this. Then write the remaining terms here. So now g of x is equal to, adding minus 41x, 70x, it is plus 29x. Take these two terms to the other side. It becomes 10 minus 29x. Now g of x is 10 minus 29x divided by this term. This is in product, right? So we get 1 minus 7x plus 10x square in the denominator. Now you can rewrite the denominator 10x square minus 7x plus 1. Now you can factorize it. We are going to apply, after finding g of x, we are going to apply partial fraction method. So this 7x can be, okay, product is making this into the factor form. As you know, take the sum and product. Product is 10 into 1. Product is 10. Sum is minus 7. Splitting 10 so that you get minus 5 minus 2. So multiplying you get 10. Product is 10 and adding you get minus 7. Okay. Sum is minus 7. Product is 10. So this minus 7x can be splitted as, you can take this minus 5x minus 2x. Now combining the first two terms 5x into 2x minus 1. Combining the last two terms minus 1 into 2x minus 1. Taking 2x minus 1 as common from the first and the second term. Within bracket 5x minus 1. So now we apply, this is our g of x value, okay. So after finding g of x, we apply partial fraction, a by first term, b by second term. And we are not going to use partial fraction actually. What we are going to do is, you can take this to the numerator. So whole power minus 1. This is also whole power minus 1, okay. Apply this formula and you expand both the series. So we get this expansion of this form, okay, applying that formula. So now this can be, okay, after expanding 1 plus x square form, this can be written in the summation form. Next step, summation 5 power n x power n. Here summation 2 power n x power n. So g of x, here g of x is generating function. So next step, you write generating function summation n is 0 to infinity a n x power n. Here you can write summation 5 power n x power n. Summation 2 power n x power n. N is from 0 to infinity. Also you have a constant a and b here, okay. So you have a and b here, also the expansion. Now comparing the coefficient of of x power n, comparing x power n coefficient a, n. What about coefficient of x power n here? A into 5 power n, that is the first term. Coefficient of x power n is b into 2 power n. So b into, actually this is the solution, okay. So an is the solution. So now we got the solution, and next thing we are going to do is finding a and b and substituting here, which you can do it on your own because condition is given. A0 is 10. When n is 0, you form an equation, okay. Similarly, when a1 is 41. So when n is 1, here when a1, you can substitute n1 and equate it to 41. You get two equations. Solving 2 and 3, you can find a and b. That's, you can do it in your own. You get a is 7 and b is 3, okay. After finding a and b, what you have to do is substitute it in this equation number 1, that gives the solution. So we substitute a and b here so that we get the solution. A n is equal to 7 5 power n plus 3 2 power n, because a is 7, b is 3. So this gives the solution of the given non-homogeneous recurrence relation using generating function. All that you have to do is learn the general equations, general expansions, also symbol logic we are applying here. If you learn all the symbol logic and expansions, really it will be easy for you to solve, okay. Important session, please you can go through it and try this question on your own also. You can practice it so that it will be easy for the examination.